Hello students, and welcome to this continuation of our lesson on the area of 2D figures. Today we're going to be talking about kites and rhombuses. So before we talk about what their areas are, let's actually define what these figures are. So they look kind of similar. They're both kind of a diamond shape, right? But you see there are these slight differences where you have this elongated pair of sides over here on the kite, and it looks like the rhombus, all of the sides are the same. And that's really going to be the main distinction. So when we're talking about a kite, we're talking about a figure that has two pairs of adjacent sides that are congruent. So we'll say that this side and this side are congruent, and then this side and this side are congruent. So over here, I might say that I have two pairs of congruent adjacent sides. Another important thing is that a kite is never going to be a parallelogram. So we know that it is got two pairs of congruent adjacent sides, and it is not a parallelogram, so the sides will not be parallel to the opposite side. Then something else that I know is that the diagonals are perpendicular. And what are the diagonals? Well, the diagonals are these lines here that run across the middle of the figure. So they go from vertex to vertex and they cut the figure. So these diagonals here form a right angle, or they are perpendicular to one another. And what's also interesting is that if I'm looking at this diagonal specifically, this diagonal will be bisected. So that means that this side will be congruent to this side. Our area formula for a kite will be 1/2 the base, or I'm sorry, 1/2 diagonal 1 times diagonal 2. Where this is diagonal 1, and then this is diagonal 2. And the reason that this works out is that we can imagine, we see how these two sides are congruent. So I could actually take this triangle and move it here. Likewise, I could move this other triangle down here. And what I'd see is I would create a rectangle that has half of the height of the kite, but still has this diagonal, D2, as the width. So we have 1/2 of diagonal 1, that's this height here, times the second diagonal becomes the width of the rectangle, will give us the area of the kite. Now, rhombuses we're going to see are similar, but they have some important distinctions. So the most important thing about a rhombus is that it has two pairs. It is a parallelogram, so it has two pairs of parallel sides. So those are parallel, and then those are parallel. So we know that the rhombus is a parallelogram, but it's a very particular parallelogram. It's a parallelogram in which all four sides are congruent. So we know that a rhombus is a parallelogram all sides are congruent, and then we know something about the diagonals as well. So if I draw my diagonals in here, so again, similarly, a rhombus, the diagonals will bisect each other. Or, I'm sorry, the diagonals are perpendicular. And this little symbol here means perpendicular. But additionally, we say that our diagonals bisect one another. So what we'll see is that if we have this diagonal here, these will be congruent because they're being bisected. And then along this diagonal and here, these two segments will be congruent as well. So, interestingly enough, our area formula for our rhombus is actually going to be the same because we can do this whole cutting and moving thing again, right? So we notice that we have these congruent sides, so we can take our figure and I could move this triangle down here, and I could do the same thing over here because we have this congruent side, so I could match them up quite nicely, and I'm going to create a rectangle that is half the height of this rhombus. So again, we say that the area is equal to 1/2 times diagonal 1 times diagonal 2, where this is diagonal 1, and then this is diagonal 2. Alright, so before we get started on our assignment, what I want you to do is complete this Venn diagram as a reflection over our notes. So this Venn diagram has some information already in here. We know that a kite is not a parallelogram, we know that a rhombus is a parallelogram, and we know that both of them have a diagonal. So what I want you to do is fill this out with some information about kites and rhombuses and see what is the shared information in between them and what makes them different from one another. When you're done with that, let me know so that I can sign your reflection and then get started on your 10 practice problems. Have a wonderful day, and let me know if you have any questions.